Okay, I'm gonna just go through this. I might not be exactly coming in live because of the some of the delay. So I'm just gonna go through this. So let's start with the data lake ETL performance. The idea behind optimizing data factory and data flows specific to a data lake ETL performance is to focus on the idea of optimizing for file sources. That's going to be your sources and your sinks that are going to be specific to a data lake store or blob store within Azure. And when you do that, you're going to be sometimes writing to SQL database, sometimes just writing back to a folder in your container. So the first set of timings I'm going to show for you as an example are going to be specific to how you would work with those files. So I took for an example, I have a file that was 421 MB, has 74 columns and almost a million rows in it. I did just a single derived column on it. Now, in this case, this was a blob store. And what happened was when I set it to a memory optimized 80 core Azure Integration Runtime, I was able to transform this end to end that amount of data in 4 minutes. So what you're going to see is you're going to get a lot of impact on the time it takes to transform data at scale in the lake when you use a larger integration runtime. And so let me just quick flip over and show you what I mean by that. So I'm going to flip my screen over to my browser, and that is not the screen I wanted to show. That is when I was trying to troubleshoot. There we go. So this is an example. So in this case, I'm using my loans demo. And actually, this one's a little bit more complex than the example timing I gave you of the 4 minutes. In this case, I'm also doing some masking. So the assumption here would be that this would be PII data, and I'm going to do some things like I want to null out some important columns, or I want to then hash some columns so that I'm taking out sensitive data. When you do this, in this case, this is pure lake ETL. This is going to be lake, this is going to be CSV in, and then just a folder out. Now, this is the most optimized way to write a data flow that is going to work with data lake. And what I'm doing here is on the source, under optimize, I would actually leave this as current partitioning. Don't set partitioning. What I had set here was set partitioning, and I had manually set the number of partitions down to 2. The only reason you'd want to do that is if you know you're going to be executing on a smaller integration runtime where you're not going to have a lot of cores or a lot of nodes available to you, and you want to physically intentionally set the number of partitions to a lower number. If you use current partitioning, this will allow Data Factory to leverage Spark and to be able to then partition the data and the processes such that it can adjust to the size of compute that you're giving it. So what happens then is when I go to execute this from my pipeline, let me go over to this pipeline here, and this is my pipeline that would run that data flow. I can then set a different size integration runtime on it. So if you're using the default auto-resolve integration runtime that comes out of the box with your factory, when you set that, you can set, and you can set dynamically, the type of compute and the number of cores right here. But a more common way is to just set it from the integration runtime. Now, if I were to apply, let's say, I think in this case I have 80 cores set on this integration runtime. Now I can partition my data even more for large numbers of files and large data. That's going to create a much more better partition distributed set of data on disk for me to work with, and in memory as it forms the data frames inside of Databricks and Spark. So the way that I would change that is over here in Manage. You'll see the integration runtimes set here, and I'll show you the integration runtime that I'm using here, my Dataflow cluster. I will tell you that in this case, I'm actually using my Dataflow cluster both as the integration runtime for the activity as well as for my debug session. So my debug is also using that same cluster definition for that Azure Integration Runtime. You don't need to use a large cluster for debug, because your debugging is going to work with sample data and you're only going to be looking at a snapshot of the data. But I'm just using it because I want to also run this activity from my debug cluster. So the debug session, when you turn it on, will spin up an interactive cluster in Databricks in the back end. When you go to run that from, oh great, I'm getting a login from my my browser. Give me a second. Great timing. There we go. When you run that activity then from a pipeline, Data Factory will execute that from a job cluster. If you set a TTL, you can then execute that activity from a warm pool, so that the VMs, the hardware being used for that job, can be held onto for you. So it's important to think about it this way when you're optimizing these data flows. Every execution that you make against a data flow activity is going to use a compute that is isolated just for you. It is yours. So you can hang on to that if you want to. So in my data flow cluster, I'm using memory optimized, total of 80 cores, 64 for the workers, 16 for the driver. And I have a TTL of 4 hours. So after my last job completes, I will have 4 hours left for that data flow activity to use that same set of hardware. So all that data flow has to do then, Data Factory just has to spin up the Spark cluster and then spin that job, execute that job for you. So it works. It'll start up a lot faster. And so let me give you an example of what that looks like. So back here on that data flow that I was using for the demo, I'm using that data flow cluster, and if I click on debug, there's a button, there's a drop down right here. You can either say use the debug session that you've already set, use the cluster and the integration runtime set for that, or you can say use the cluster that's in my activity. So this will allow you to have a smaller Azure Integration Runtime and cluster just for your debugging, but then when you go to test it, use a larger cluster. Use a cluster that you've set for the integration runtime inside of the activity. And what's nice about that is it lets you sort of test this in an operationalized integration runtime without needing to use the trigger now. Trigger now requires you to publish that first. In this way, I can just run this right from my branch here in my GitHub, and I don't have to publish it. So I'm going to do that. Now, when I run that from here, it'll use that cluster. Now, if that cluster is not already spun up, you'll have to wait for that. So what that looks like is, in this case, if I look at the monitoring for that data flow execution, the total time to execute was, let me go back here. The total time to execute was almost 5 minutes. But of that, almost 4 minutes was just waiting for Databricks to form. Okay, so once it came up, then the total time for execution inside of Spark was much less than a minute to execute all this end to end. And because I had 64 cores of compute, I was able to get a full 64 partitions. So the takeaway from what I'm saying here is that setting the partitioning on your files, sources and sync, to use current partitioning will allow you to scale as you change the size of your integration runtime. If you have a specific reason why you want to have fewer partitions, you can definitely set that through set partitioning. Now, one other thing I want to say is when you use this option under debug to test your data flows in the pipeline, if you use the activity runtime, Data Factory treats that as if it were an operationalized pipeline from the perspective of that cluster will still stay up as a warm pool. So what happens then is if I run that even from another pipeline, if I execute another data flow using that same integration runtime, I will take advantage of the warm pool. So here's another data flow I have that took a total of 6 minutes to run in debug. When I look at the cluster start time, the cluster start time was just a minute. So that's because it was using warm pool. I had the TTL set to 4 hours, so it was able to take advantage of that. And all of the execution time then was spent in these other transformations. Now, notice that if you've used data flows before and you've used our monitoring, we give you timings in each of these. Let me go back to my other pipeline and show you that. When you look at the eyeglasses, the Harikari icon, when you click on that, you will see the timing that everything took, all the stages took within your data flow. You even get the time that it took to process the data, the I/O time that it took to write that data. Notice how in this second one that I ran against the warm cluster, it didn't give me any of that. I don't have any of my partition information. I don't have any of my timing information. And why is that? That's because there's a new feature that just landed this week that Dan has documented and that we're going to do a blog about later this week. That landed, that's called a logging level within data flows. So now at your activity level within the pipeline, you can set your logging level. So if you have pipelines and you have data flows in those that you don't require all of that deep introspection, that verbose logging, you can turn it off and you can save a little bit of performance that way. So if you say none, we will not log as much. And so you can say none, a basic, which will give you the basic set of logging. I believe it does not give you the partitions, but you do get the timings. Verbose is what you see today. Verbose is the default, which is going to give you all the partitions and the timings of every stage within your data flow. So a recommendation might be that you want to set verbose if you're troubleshooting, and then set it to basic or none during normal operations so that you can get a little bit of a better performance on your data flows. All right, so let me go back to the slides and I'm going to see if I can figure this out. Hey, check that out. It worked. All right, so let's move on through the rest of the sample timings for files. That was a database. Here we go. So here is end-to-end blob store with one single derived column. All I did in this case was just mask 3 fields. I had that same size file with almost 1 million rows and 2 minutes end-to-end on that optimized 80 core. The memory optimized 80 core is what I was using in this demo as well. So I was able to get that to work in 2 minutes. My 4-minute demo you saw was also doing aggregations minutes, and it was also a cold cluster, so the hardware in the cluster had to spin up for that to work. So some key takeaways: when you're using large file sizes, large data sizes, you should use more than 16 vcores with memory optimizer general purpose. In fact, for almost every workload, unless it's going to be something that's going to be very small, sort of a couple of seconds of activity, we would recommend memory optimizer general purpose. We do offer compute optimized as an option, but that is not necessarily recommended for operationalized pipelines. CSV to parquet format we found has about a 45% time overhead in comparison to going CSV to CSV. CSV JSON is 24, but I will say that in general parquet works much better as a file format in the lake with Data Factory, with ADF, and with data flows in particular. So I think I have one more slide on the file. Yes, so the other thing I want to say about the file with ETL and Data Lake with data flows is that you will see proportional increase in your performance as you add cores, and which is why using the setting of current or default partitioning is recommended. In fact, let me just go back to that for 1 second. I want to just kind of reiterate that here in the UI. It might be easier for me to show you. So back in ADF in the data flow with this is going to be a SQL. This isn't the one I want. Let me go to the file-based ETL. In Data Lake ETL, to have sets current partitioning, and then in the sync as well, set this to current partitioning. Typically, in partitioning with files, you may need to do this if you want to do some things like if you want to set up the key folder partitioning that will allow you to do some things like maybe set a date-based set of partition folders. You can do that here, so that would be a reason to set your own partitioning. But if you're not going to do that sort of data level, value level partitioning, just stick with use current partitioning, and that'll be the fastest to achieve your best performance with those files. Let me quickly see, I think there might have been one other topic I wanted to show in there before I go back to the slides. If I say that, no, I think that's fine. Let's move on to the next section. Okay, so the next section we're going to talk about is when you are doing ETL in Data Factory with data flows, and you're doing that with databases. So let's focus first on SQL database. So what you're going to see is, based on the testing that we've done In this case, we had this testing was a data set of 15 gigabytes. We went from a CSV to SQL and then SQL to CSV. We used general purpose. We had 16 cores that we gave to the workers. Now, what happened in this case is we were able to increase the performance of different stages of your transformations as you went up from 8 cores to 64 cores. You can see the timing in the second column there at the bottom. And so the stage timing decreased as you went up. Now notice that the amount that you increase does the amount that you see an improvement in your performance does decrease as you get higher. So there is sort of a leveling off, and there is an economy of scale that you lose after a certain level. But what happens then is that the sync time also increased. The sync time is a little bit tricky in data flows because it's going to include both any transformation that is taking place before that. When it reaches that sync stage, it then has to land that data in your data store. So you'll see that in most cases, the sync time does not necessarily increase with the addition of cores. What can increase the or improve your sync time is to increase the throughput on your database, so that you can have more throughputs as we're writing the rows and we are serializing those rows in your target database. On the DW side, on the Synapse DW side, the SQL pools, very, very similar sort of results that we saw as well. We use pretty much the same amount of data, very similar. The sync time was actually quite a bit less when you got up to 64 cores on here. The big difference in loading in SQL DB versus DW is we almost always recommend using Polybase, and so we did these tests with Polybase. Now on the Cosmos DB side, we didn't really see the improvements as we added more cores. So really, the way to get improvements with Cosmos is to increase the throughput on the Cosmos DB side. So let me go over to my UI before I go to the next section. Let me show you some of this in a Data Factory. So let me switch back over. Okay. So on the SQL side, when you are, first of all, writing data to your SQL database, in this case, I only have insert set. That's because I don't have an alter row on here. When you have an alter row, you can then select your delete, upsert, and update. The way to get the best performance on all of those operations when you are writing the data to Azure SQL database is to first start with current partitioning. Again, the same thing. Now, as you saw from that chart, you don't necessarily get the same, the exact same proportional improvement in your performance when you add cores. So this is where your setting of partitioning can be a little bit more beneficial. In most cases, unless you have deep insights about your data, round robin will be just fine. So if you know you're going to apply, let's say, a 16 core set of worker nodes to your process, you could set 16 round robin partitions on that and see if that would be a much better performance for you. Additionally, if you have some insights into your data, you get a little bit smarter about that partition. You can use hash partitioning on that. So you can set that again to 16, and then you can set some of the high cardinality columns in your data. So you can set that to ID, or you could also even do a composite key against that as well. But one of the key takeaways that we found during our testing in performance engineering with data flows is that when you're reading from a source SQL database, the best performance is always going to be to set your partitioning to source partitioning. Okay. Now you can set that actual partition two different ways. You can either pick the columns again like I was doing earlier to get some uniqueness out of that, or you could even set a query. So the query would be a little bit more, less generalized or more generalized than picking specific columns, but either way will work just fine. When you set the column, then you can do the same thing you did when you set the round robin and the hashing on the sync. You could say, give me ID and give me these 16 partitions as you read that data in, and partition that data based on the ID. The source partitioning is the recommended partitioning to set when you're reading from SQL database. And then on the SQL DW side, let me just actually add one here just to make it easy to show you. So I'm going to shrink this down a little bit, use our new zooming capabilities that we have in Dataflow. Give myself a little bit more real estate. Also, if you want to get more real estate in your vertically in your diagrams, you can also right click and you can say hide reference nodes, and those reference nodes that hang off of your joins and your other transformations will disappear and give you a little bit more real estate as well, and then you can toggle that back on as well. So when you're reading from Synapse DW, let's see, get this one here. I'll make this full screen for you. The keys to making that perform better are going to be, first of all, in your source options to use staging. So this will allow us to use polybase here for the reads as well. And then something new that we added on the sync side, this would be actually, I take it back, this is not for DW, this is for database. This is going to land this week as well, so you'll see this light up by the end of the week. Probably for most of you, you'll see it next week. Is on the sync side of the SQL database, you can now set error row handling, just like you can in copy activity. So the default is what you see today, which is stop on first error. So from a performance perspective, since we're focusing on performance and optimizations here today, this is going to be the quickest way to write data. However, the first time you encounter an error, that will fail. Now, if you set continue on error, then the data flow will continue to write in your database tables even after an error was received. And that error can happen. I just realized, so Dan is pointing out to me, and I'm telling you all this while I'm not showing my browser. Thank you, Dan. So I apologize for that. But what will happen then is that when you set this, and you say continue on error, we can continue to write the rows, and you will have the option of being able to output the rejected data as well to a storage account. So you'll be able to get all of the rows that failed, and the errors that came back, things like truncation errors or constraints from your target database. So let me go back over that because I realized I didn't change my my streaming tool correctly. So let me go back and show you what I was showing before. So the things I showed you in here was from the source to read quickly from a SQL database, set source partitioning, set your number of partitions, set your column or a query condition, and that will be the fastest way to read. On your Synapse DW, your SQL pools, go to my Zoom, go over to my SQL DW, and what I was saying is set the enable staging here on your SQL DW source. That'll be the fastest way to read from Synapse. All right, now I can go back to my PowerPoint. So by the way, so back on the error row handling that I was showing you just a second ago too, is that that'll be landing later this week and next week. The fastest operation will be essentially ignore and just fail on first error. However, you can always say continue on error without writing to a log, which would be a little bit better. And then the most costly, most expensive would be to also writes the errors out as well. But it's very helpful for you from an operational sort of enterprise ETL perspective to know which rows failed and why. Alrighty, I'm about halfway done, so I think we're in good shape here. One of these days I'm going to master this whole streaming thing. Who knows? A couple years from now. So let's talk a little bit about optimizing on the transformations within data flows. Let's first talk a little bit about the window and aggregate transformation. The reason why we focused on the timings on these is because these are the ones that seem to trip up users the most. And the reason for that is because they are transformations that can be a little bit costly and can sometimes cause larger sort of spikes in your timing for your data flows. So what we did see with these is that you can increase the throughput and the performance of these transformations equally so from the window and the aggregate by increasing the core count on your workers. So you see they both had similar improvements as you scaled up. And again, definitely recommend a minimum general purpose when you're doing windows and aggregations in your data flow. Compute Optimize is just not enough RAM per core. It's not going to perform very, very well. for you. Now, the reason why we looked at these two is because a lot of times we've seen customers, we've seen users in the past use things like a window aggregation, and then instead of actually using windows of time or values, making a sort of a dummy value to go across all of your data, and then using row number or rank in there. While that is valid, that's not going to perform as well as if you were to use, say, surrogate key for your row number, or to use the new rank transformation for your ranking. And the rank transformation has also dense rank in it as well. And I did it again, didn't I, Dan? I did. Oh my goodness gracious. There you go. So I'm back to my PowerPoint presentation, and yes, so I don't think I need to repeat that, but I think you got the takeaway from that. Now, when you look at optimizing, this actually talks a lot about what this actually is just a repeat of what I said essentially. When you look at optimizing, when you're going to use row numbers or surrogate keys, use that transformation instead of window, unless you use window if you absolutely want to number those rows based on partitions of data, essentially the over clause within the window transformation. And then on the ranking side, the same thing, use the rank transformation for that instead, unless you're going to use with segments of data. And I apologize, everybody. I don't get your messages until I'm like 3 minutes past where you're all at. I think I am live myself. I'm a little bit ahead of where the live stream is coming in at. Apologize for that. Okay, so we also did some TPCH timings. Now I'm not going to go through all these in detail. I have 3 slides that have some real deep intel for you in terms of the performance of data flows against different sets of data. And what I would encourage you to do is to use the link that I put in the live stream earlier with the slides in it. And when we post this video, this replay, I'll put the link in there as well, so you can look at these numbers in there for you too. So this was 600 million rows. The data set sizes were 16 gigabytes and 76 gigabytes. We ran with a total of 175, 190, and 200 different partitions based on the number of cores. The number of worker cores are at the bottom. And you can see the time that it took to do a left outer join and exists in a lookup. Now, the reason why we're looking at left outer join, exists, and lookup in this case is because you can get similar effects or similar outcomes from using those 3 different transformations. So you can look at how to use them in different scenarios. Now, the lookup transformation itself is essentially a left outer join, but the lookup transformation can be optimized for certain scenarios. So notice how I was able to scale better, and let me show you how that essentially manifests in the tool and why you would use one over the other. I know why it's not working, because I keep clicking the wrong button. I think I got my switch to my browser right this time, folks. So pretty soon, by the end of this, I'm going to be ninja level YouTube streamer, or at least passable. Okay, so what I want to show you is from a lookup and a join perspective. Let me come over to this data flow over here. So this is a general lookup that I'm using right here. This is essentially implemented in the back end as a left outer join, but it has a lot of optimizations in it for this specific idea of looking up reference data. In this case, the setting is the default of match multiple rows. So anytime my title in my incoming data is matched to the title in my lookup data is down here in this source, in this derived column down here. Anytime I do that, I'm going to get every single match because I have matched multiple rows and it's a left outer. If I deselect that, now I can say match on the first row, any row or last row. Okay, if I say any row, Data Factory is going to go ahead and just going to randomly pick any row. If I say first row, then I can set a sort order and tell Data Factory to pick the first or to pick the last. So previously, before we added this a few months ago, you had to essentially do this in 2 steps. You had to do a lookup and then an aggregation to distinct those rows if you didn't want all of the matching rows. And so what happens here in this case is the lookup can solve all these problems for you in a much faster way. In fact, we now have an even better way to do it. This came out just this week, so it's not in my slides yet, but I will update the slides with it. So if you're going to do a lookup, And the best case scenario, the best fit scenario is doing something like a surrogate key lookup like I have over here. If you're going to use that inside of another stream, inside of a derived column, you can use what's now known as a cached lookup. This will be the fastest way to do a lookup, so this will be even better performance for you. The way you do that is you set your sync to be the sync type of cache. So instead of writing to a data store, you write that into memory, and the Spark cluster that is isolated for you in this execution will keep in memory this data in this data frame. So in this case, I'm doing I'm adding this to the surrogate key. So I'm getting where I left off with my last run. I'm getting the max surrogate key from my database table. And then I'm just two-integering that here. I could have done that inside of the SQL script as well, but I did it as a separate step for whatever reason. And then I'm storing that in memory. So I say stored in memory. So this is called a cache sync. I made my sync as a cache, so it's not going to write the data to store. It's going to put it in memory. Now I can access that up here. So in my derived column, all I'm doing is taking my incoming surrogate key, and that I'm adding to it the max value coming from that cache. So max ID was the column, and I'm saying give me the first row. By the way, we only have outputs, which gets all the rows from the output, and then you take the first element or the first row from that. We also have an output that we're going to be adding here very soon, so you don't have to do this kind of syntax here. But this is fully documented. We have some demos on it and some blogs on it, some videos on it as well. So that's a lookup. Now the other thing I wanted to show you was back in the joins. So if you were doing a join or even lookup as well, for that I'm going to go back to this. Is this the one? Yes, this is fine. In the join, there is this idea in the join under optimize that you can do some optimizations. And the default for that is broadcast auto. All right, so you don't necessarily really have to go in and change the partitioning options very often in the join, but the broadcast is the ability for Spark to be able to send that either one side or both sides of the relationship in your join or your lookup, or exists as well, to the nodes to get data locality and to make it work a little bit faster. If you say auto, then Spark will make that determination for you. If you do that and you want to increase your performance, again, add more cores and memory optimizer or general purpose to your data flow so that more of that data can be broadcasted. If you say fixed and you select, let's say, the right-hand side, because maybe the right-hand side is smaller, it's just a lookup, then this will force Data Factory to do the broadcast down to the node. Just be aware that the nodes have to have enough memory then for that to work, or you will get an out-of-memory error on your execution, and then you have to come back in and either set a larger integration runtime setting or go back in and change that to auto or off. You can turn it off as well. And I just realized as I've been saying all this that I'm throwing a lot of information at y'all. So I'm just trying to give you some pointers, and you can always go back in and look at the awesome docs that we have that'll give you more details, and we have a lot of videos and blogs and all that kind of stuff. Let me not focus in too much on this slide, and please put in the chat if I didn't change the slide to the slides. But we have a full graph for you, a full matrix of different performance based on different IR sizes. We have inline dataset types as well as dataset types. We have what's interesting about this slide as well, this chart as well, is it also tells you how much throughput we get based upon the size of the cluster that we were given, the size of the IR. So the throughput is in megabytes per second, and that is listed here. So that's an interesting stat for you to see as well. Now we have, in fact, this slide also is for Data Factory proper as well as Synapse. So an important note, when you are using data flows in ADF, that is using Azure Databricks behind the scenes. When you are using data flows in Synapse Analytics, that is using Synapse Spark behind the scenes. So slightly different performance profiles you're going to get. All right, so this slide shows you what those differences look like in the throughput as well as the load times. Okay, very good information. So I'll leave that to you to go and look at and enjoy. Two more sections. Let's talk a little bit about how to use the monitoring tool to be able to improve your performance and look for hotspots. So like I showed you earlier, you do get the timings, you do get the partitions. In fact, the partitions, the bottom right will have skewness and kurtosis. So you can look to see if maybe you're getting hotspots in your partitioning. You're not typically going to get that in default or current partitioning, but if you do set the round robin in the hash, you do want to check your partitioning on your runs to see if those executions are not distributing the data well and could be causing some bad performance on that. You'll know if you're getting bad performance or good performance by looking at the timings on each of the steps or the stages within your data flow. So when you bring up this monitoring view, you can look at the transformation stage times to see how long they took. We show these to you in stages because the optimization of the executor for data flow will be able to group some things together and say these things are all going to be run together in one stage, and it'll tell you how long that took as well as the partitioning for that stage. Now, one of the things I think you should always focus on when you're looking at improving the performance or looking at overall understanding of the performance of your overall data flow is to look at the monitoring view and look at the sync processing time. The sync processing time, we're going to be adding a few more metrics to it over the next couple of weeks, but at the bottom it does give you the processing time of the IO or the actual write times down at the bottom right as well. That's important to know because it could be that your data flow completed in a minute, but maybe there was some locks on your database table, or maybe there was some resource contention right into your container. In that case, you will see that surfaced as the sync processing time. And that can show you that the time was taken in actually writing the data. You're not going to be able to optimize your data flow. You have to then go to your target system, your target store, and optimize that. Either add more throughput to it, maybe you add more containers, or ask for additional resources to be lifted, some soft limits to be lifted on your storage account. The top right one is one that always interests folks, and that is the cluster startup time. Remember, like I said, we isolate every execution, every data flow in a separate cluster environment. That is the Databricks model, and we have taken that through into Data Factory for data flows. What that does mean, though, is that you do need to wait for a just-in-time cluster to become available when you execute your data flow or when you start up your debug session. Your debug session lasts for 60 minutes, and you can also change the size of your debug session. But the cluster startup time is really dependent upon Databricks being able to acquire the compute and networking resources to be able to stand up that environment. Like I showed earlier, let me switch back to my browser while I talk about this. And this is always tricky because I always forget. I think I got it. But when I showed you this one earlier, when I executed this pipeline right here, it took 4 minutes and 54 seconds. This was a cold startup, so it took almost 4 minutes for a cluster. I used TTL so that I can hold on to that hardware just for me. And that's what we do. We hold on to it just for you. And what will happen then is the next time you execute that, the startup time is down to a minute. So I was able to use that warm pool. When you are executing directly from a debug session, if I just click this debug button or the use dataflow debug session, that will then allow the data flow to execute against the already warmed up cluster. And your startup time will be in the seconds. It'll probably be about 10 seconds to get that job over to the cluster, the payload to the cluster, and have it started. All right. My timing has been splendid today. I'm like right on time. Last section, ETL performance best practices. Let me wrap this up into a series of best practices for you. We will continue to blog on this too. I'll put the blog link in the, actually, you know what? I do have the blog link open here. So let me see if I can get this for you while I'm talking. I'll make sure these links are in the shared video as well, but we'll continue to blog on these things. But let me start with file partitioning. Maintain current partitioning. Avoid output to single file. I forgot to talk about that. A lot of users of Data Factory, especially if you're new to data flows, will see that. Let me do the old switcheroo on you and show it to you again. I probably missed this piece, so I'm going to show it to you now. Once this comes up, I'll share that link with you. When you are writing files, if you're working in a data lake environment, data lakes are meant to be working with partitioned files primarily. However, there is the case where you may want to write the output to a single file. If at all possible, we recommend you avoid that. The time it takes to merge and coalesce partitions into a single file is a very, very costly and expensive operation. And the way you do that is when you're writing to your data lake in the sink, you have these other options. You can just use default for the file name option, which means that we will write a series of file names that will use the file extension based upon the kind of file you're writing, the Parquet, Avro, CSV, but the file name will be based on the GUID coming from the job execution from the job scheduler. So it's kind of a gnarly, nasty looking name. So a lot of customers will want to go ahead and users want to take that and make that into a single file and just say, write that out to something nice that's readable. You know, call something like myfile.csv, for example. The problem with that is that all the coalescing and the merging of those partitions takes a very long time, and you see you have to set single partitions, so you lose the advantage then of the partitioning once you make it to that final stage, and you bloat that final stage in your data flow. So 2 recommendations on that. One is avoid this if at all possible. This, by the way, is a great option when you're just testing. And you want to go ahead and just test to see if you're getting the right output and you don't want to get all the different partition file outputs. That's fine. When you then go to execute this in an operationalized mode, set it back to defaults. Now, if you do have to set the single file, a recommendation is let your data flow, your ETL jobs run as partitioned files. Put those partition files into a separate folder. Then run a second process that will go ahead and coalesce and merge those files for you. And for that, you can use either copy activity or data flow to do that. And so what would happen is your pipeline would look something like this. You'd have a pipeline that executes your primary data flow, and then afterwards either has a copy or a data flow activity that will coalesce and merge those files into one. And that way then you can separate those processes and you won't have to wait for your ETL to finish waiting for it to merge into one single file. One other point while I'm in the UI, this might be my last time in the UI, so I want to show you this as well. Particularly if you're going to work with a smaller size cluster for your debugging, you can set the size of the sampling when you are looking at your results. When you are validating your data in data preview, the number of rows being, not the number of rows, but the amount of data being sampled is set here under debug settings. Each source, you can set a different row limit. So if you have a data flow that has, I'll just add another one here to show you, that has multiple sources in it, you can set a different sampling size, a different limits in here for debug. Okay, so if you have a small cluster you're using and you just want some quick results, you can bump this down. If you have a larger cluster and you want to do some debugging with larger amounts of data, you can bump it up in here. You can do all that here from the debug settings. And additionally, when you execute this from a pipeline test, you can even test that in the debug pipeline as well. There's a setting in each source under source settings called sampling, and you can enable sampling here and set the same row limit here in sampling so that when you run it from a pipeline, you'll get that same effect of sampling. Just keep in mind that you'll want to either it's a good practice to either parameterize that, or just be sure to make sure you go back in and disable this when you operationalize it, because otherwise your operationalized pipelines will work on sampled sets of data. All right, let's go back and finish up on the presentation. Okay, so some other best practices. Let's see if I missed anything there. I don't think so. There's some guidance around setting partitioning. If you're going to do manual partitioning, that's an advanced thing. You really should need to go into manual partitioning unless you've exhausted the performance that you can out of current partitioning. When you are reading from sources, I already mentioned these. With SQL DB, use the source partitioning with high cardinality. Your reading is limited by the I/O of your source, and the writing is limited by the I/O of your target, of course, as well. When you're doing lookups, use a cache lookup. That's going to be the most effective. Lookups are going to be faster than using a left outer join if you can do a lookup for a reference lookup. Use rank for ranking unless you need to set a window of the data to rank across. If you're ranking across the entire data set, use rank. If you need a row number or a surrogate key across the entire data set, then use surrogate key instead. Talked a lot about this. I don't think there's anything new in here in terms of data preview. We did talk about setting the size of it, setting the sampling. Remember, when you set sampling, when you're doing joins, I've run into this a lot with users of data flows, is that when you're doing a join with a sample set of data, you may not get the match that you expect. So you should always look at being sure that there is matching data in those data sets when you're sampling and you're looking at validating your joins, or just assume that the join is not going to give you the results that you're looking for. You can use sampled data in, if I get a chance, I'll flip back over and show you that before we're done here, that you can use sampled data for your joins so that you can guarantee you do get results in your debug. Best practice in the sync, talked about output to single file. There is also ways to run pre and post SQL scripts. Of course, now those scripts have to run before your data flow is done, so that can take a little bit more time. I mentioned error row handling as well as one thing that can add more features but slow down your data flow a little bit. Talked about using TTL. Okay, so at the end of the slide deck, there's 3 slides that I think you might find interesting to have in your back pocket as well, in terms of the performance we saw with different numbers of cores based on the different types of integration runtimes. In this case right here, I used the general purpose 4+4, which is the same Azure IR configuration that's the out-of-the-box default auto-resolve. This is what you'll be using if you don't build your own integration runtime and you are debugging. So you're only going to get 4 cores in the worker, which means you're only going to get 4 partitions when you're setting using current partitioning. So if you want to over partition, you're going to have to partition across that within that single worker node, which would not be optimal. So you can increase these by increasing the number of cores. We recommend general purpose at a minimum and greater than or equal to 16 cores for most operationalized workloads. I give you some timings here. The cluster startup time is 4+ minutes. I/O time, transformation time, and sync processing times. Now, when I tried that on Compute Optimize is available to you. It's less expensive. It has much less RAM on it. It's a lower RAM to core ratio for the VM. This one I ran with 8+8, so you got 8 cores for the driver, 8 cores for the worker. And in this case, I got fairly decent times actually in this case. I actually got 20 seconds of writing the I/O, 35 in transformation, and 40 in post-processing. When I went to memory optimized, then I got the best times possible. I got 19 for I/O, 17 for the transformation time. In this case, I used the 64 worker nodes, and you saw in my earlier demo, I showed you this as well. I got 64 partitions across that data. So our hope is that we're able to surface enough information to you through this process to give you the information you need to be able to tune these, and hopefully this set of background performance benchmarks in the slide deck will help you to understand whether or not you're getting the most out of what you're trying to do in your data flows. Let me go back to show you the one thing I'd promised I would show before I go, and that is that under debug settings, if you are looking at a small sampling of data, if you only want to, let's say, sample 100 or limit to 100 for your debugging, but you want to make sure your joins work, you can use a sample file. So you can point to a file that has maybe IDs 1 through 100 in it on both sides of your relationship, both the left and the right, and then that way you'll be able to ensure that your join is working instead of taking a instead of it being a guess or being a crapshoot because you don't know if those rows are going to be part of the sampled row limit that's in there. One of the way you can achieve that as well is if you are having database sources. When you do that sort of sampling and that testing on your database source, go into the source options and write the source settings. Oh, duh, sorry, my bad. That's not a SQL sync. I want to go to this one. Go to your source options and say query, and then write a query that is actually bringing in those rows. So you can say that from my table, give me all the columns, and then you can say where ID is greater than 1 and ID is less than 100 as an example, and then write that same query in your other source, and that way your join will be able to be validated in your data flow. So that's a common thing that we run into. All right, I think I covered everything I needed to, or at least that I wanted to. This recording will be out on our site. I might do some cleanup on it for some of the things that I forgot to switch over back and forth so that you don't have to watch that over again. And I'll make sure to put the links to the blogs